Yes, welcome students. Okay, right. Now, in the previous case, we studied about homogeneous recurrence relation. Of course, the linear homogeneous recurrence relation, where the power of a variable an minus 1, n minus 2, n minus k are all 1, and the constant coefficients coming. That's called linear homogeneous recurrence relation. But now here, look at that. An equals C1 An minus 1 plus C2 An minus 2 plus dot 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 plus Ck An minus k plus Fn. Extra terms coming here. I make a bracket. Extra terms, function of n added with this homogeneous linear recurrence equation. From here to here, look at that. This is what? Linear homogeneous recurrence relations. But one more terms, f of n, the function of n, is added. And this modified form, we call it as linear non-homogeneous recurrence relations. Linear non-homogeneous recurrence relations. So it would be of an equals some homogeneous function plus f of n. And this is called what? A linear non-homogeneous recurrence relations. Look at that. Here there is a function of n. A power n is not coming here. So it is not a homogeneous, but the power of the variables an minus 1, an minus 2 all are 1. Therefore, it is a linear non-homogeneous because there are certain terms in which an is not coming. Therefore, non-homogeneous. But this term is based on one or more of its previous terms. An minus 1, an minus 2, an minus k. Such a structure we call it as linear non-homogeneous recurrence relations. Okay, now look at that. Yes, this is what? A associated homogeneous recurrence relation we say. Now it consists of two parts. From here to here one part, and here is the another part. So this part we call it as the associated homogeneous recurrence relation. Associated with this particular non-homogeneous equations. There is a homogeneous recurrence relations from here to here. And afterwards, you should not add this. So this structure or recurrence relation is called associated homogeneous recurrence relation connected to this non-homogeneous linear recurrence equations. What about the solutions here? Okay. In the previous case, you have only one solution. An equals some solution where this term is based on is one of the previous term or more terms. That's what we had there. But here, not like that. There are two parts. As we see here, the regression relations have two parts. One is connected to associated homogeneous recurrences. Another one is the function of n. The solution set also will have two parts. The first part is the solution connected to associated homogeneous recurrence relation, and ANP, that's called perfect solution connected to this particular function. Where is that? Here, f of n. So we have to find out this separately. That is solution for homogeneous recurrence relation. Then we have to find out the solution for this what we call the function of n, that is called the perfect solution, and we add them to get the set of sequence which will satisfy this non-homogeneous linear recurrence equations. Okay, so these non-homogeneous regression equations have separately solution for this associated linear homogeneous regression relation, and this a perfect solution for this particular function. And that is what we see here, where an is solution of the associated homogeneous regression relation, and a and p is solution of f of n. Okay, f of n, solution of f of n. Now look at this. These are the examples of non-homogeneous linear regressions relations, because an equals, this is terms of in this sequence, and then another is a function of n is multiplied by 2. Therefore this equation, similarly here, an, its previous term is multiplied by 5, its previous element is multiplied by -6, then difference is seen, that is a new element, the successive element. With that, one function of n is added, 7 to the power n function of n is added. Therefore this is not a linear homogeneous regressions relation, but it's a non-homogeneous regression relations. Okay, so that is what you have to understand in this particular topic. The time allowed is over. The next class I will take one problem and we will be solve this type of linear non-homogeneous regressions relations. Okay, so the 2-mark questions or 5-mark question, they may ask this definition and example. If that is the case, you have to write this definition and write this example. Okay, so with that I have to come to the end of this class. Thank you, my dear students, and all the best.